So, to dwell into the difference between TCP and UDP, there are some features that distinguish the two transport layer protocols. For example, TCP uses some kind of connection-oriented conversations, which means that TCP will have to maintain a connection between any sending and receiving host or sending and receiving applications. TCP also provides reliable delivery, which means that if we have to maintain some acknowledgement for any delivered segments, and if this acknowledgement did not arrive on time, then we have to retransmit the lost segments. TCP, because of the establishing of the connections, TCP provides ordered delivery, which means that because we have established a connection between the sending application and the receiving application, which means that we have established like a virtual pipe between the sending application and the receiving application, the delivery of the segments happen in order. Also, TCP provides some flow control, in which case it controls the speed of the transmission from the sender to the receiver. So once TCP establishes the session, it needs to be able to keep track of this session, which means that TCP, we call it a stateful protocol. A stateful protocol. A stateful protocol means that TCP maintains and tracks the state of the connection, whether this connection is established, is alive, is disconnected, and so on and so forth. That actually adds some kind of overhead on TCP in terms of how to manage this connection. And that's why we see that this reflects on the header structure of TCP. We can see that it's rather complicated. So TCP uses this 20 byte header, which can be extended all the way to around 60 bytes. And this header is structured as follows. So we have source port and destination port, which is the addressing scheme that's used in the transport layer, similar to IP and similar to the network access layer. Also in transport layer, we use some kind of addressing. And the addressing here is used to track which application is sending and receiving this segment, okay, which we will talk about in a minute. Because we break the communication down into segments, we have to provide some sequence numbers to allow for reassembling these segments on the receiving application. Also, TCP provides some acknowledgement, so we have to provide some acknowledgement number to indicate to the sender that the segments have arrived correctly. The header length here uses 4 bits, and it's used in a similar way, similar to the IP header length. So again, this ranges from 5 to indicate 20 bytes, all the way to 15, which indicates 60 bytes. So the header length provides the length for the header of TCP. Those 6 bits are reserved for future use, and if they are not being used. And there are 6 bits here which indicate control bits. Control bits, these are the bits that are used to maintain the state of the connection or the state of the communication. So there are some around 4 important flags here which are being used to establish the connection, tear down the connection, and to maintain acknowledgement and send and transmission from the sending application. There is the window field, which is 16 bits, and it maintains the maximum number of segments that the sender is allowed to send to the receiver without having to wait for acknowledgement, and this is used for flow control. So the window field here is used mainly for flow control, and this will be explained later on in details. The checksum here is used as usual for checking the correctness of the TCP segment, and there is the urgent field here, which indicates whether or not this data is urgent, and in fact this urgent field is not being used at all in the TCP protocol data unit. And there is of course the optional field, which is which is used for some other services, and for by default this option field is not also used. UDP on the other side provides basic functionality, and in that case it's connectionless, which means that it does not maintain or establish any connection, and that actually saves time. Although by maintaining the connection we can provide some order delivery, and we can provide some flow control and some other useful functionality, establishing the connection end to end takes time, which provides some kind of overhead. UDP gets rid of that by maintaining a connectionless communication between the sending application and the receiving application. This has some implication that the delivery is not necessarily ordered, because individual segments may take different routes through the network, which means that they can arrive unordered on the other side. Also, UDP provides unreliable delivery, which means that it does not maintain any acknowledgement from the applications to each other, in which case if there is any segment that's lost, UDP does not provide some retransmission of this lost segment. Also, there is no flow control, which means that UDP can send very fast. This may overwhelm the receiver on the other side, which might be a problem in some cases. In that case, we need to provide some other service to take care of flow control, because UDP itself does not provide any flow control. Having said that, we see that the structure of the header for UDP is quite simple. So we have the source port and destination port. Again, the minimum we should provide in the header is the addressing scheme. So we have to have the source port and destination port to indicate the sending and receiving application from the transport layer point of view. We have the length, which provides the total length of the packet, of the segment, and we have a checksum to provide some correctness of the received segments. We have to highlight here that even though we have checksum, we do not provide any acknowledgement, which means that this checksum is only used by the receiving application to make sure whether or not this segment arrived correctly. But even if the segment did not arrive correctly, there is no acknowledgement or something that forces the source to retransmit the segment again. So there is no retransmission here. So one of the most important functionality for the transport layer protocol is the addressing, and the transport layer protocol separates the different applications using what we call the port. So each application will have to have a port number to indicate where the segments are coming from and where the segments are going to, which application is targeted by this segment. This is a very important functionality in the transport layer protocol, which is called port addressing. Using this port addressing, the transport layer protocol can separate the different communication coming from different applications, and in that case we can manage the different connection using TCP, and in that case we can also recognize the received application in the case of UDP. So the port addressing is used for both TCP and UDP, and of course some applications they use TCP and some applications they use UDP, and you can have a mix of these applications that use UDP or TCP going at the same time, and the port address will give you some separation between these communication. So the destination port is placed by the client to send to the server. So for example, if we have HTTP and web page, the browser will put the destination port address 80 to indicate that it wants to connect to a web server. For example, for email, the destination address is usually 110 to indicate that we want to communicate with an email server, and so on. Worth noting here is that the sending application has to also put the source port as part of this communication. So the source port is also important, and we'll talk about this. So the source and destination ports together will indicate the connection or the sending and the receiving application from the transport layer point of view. So here, this example is very important because it shows us the purpose of each addressing in all the layers that we have talked about. So we have addressing from the MAC layer, we have addressing from the IP layer, we have addressing in the transport layer. So if we assume that we have a source which has this IP address and this MAC address, and it wants to connect to a destination which is running some servers. So this destination host may be running multiple servers, one for FTP and one for web server. So in that case, the transport layer will put a destination port as 21 for the case of FTP communication, and will put a destination port as 80 for the case of web communication. So we can maintain those two connections or two communications at the same time from that source to that destination. So the purpose of the transport layer is to identify which application this segment is coming from and which application that should receive this segment on the destination side. The IP puts the source IP address and the destination IP address, and these are used for routing as we have talked about in previous chapter. And if we assume that the source and destination are on the same local area network, in that case, we use the same destination MAC address and source address on both communications. So the destination MAC address and IP addresses are the same as we can see. However, to distinguish between the different application communication between FTP client and server and web client and server, we use the source port and the destination port. So that gives us some overview on what level of addressing we can use in each. So these port numbers are divided into three major categories. The first category is what we call the well-known ports, and these well-known ports are for some common services, and in that case this range of port numbers is actually reserved for these common services. So from 0 all the way to 1023, these range of port numbers are reserved for the common services. The range 1024 all the way to 49,000, this is what we call registered ports, in which case if we were to develop some services, some new services that are running on some devices, we can use some of these port numbers for these services. However, if we, for example, use FTP server, this is part of the well-known services here. So you have two common ranges, which are the well-known TCP ports, and these are used for like common services like FTP, Telnet, SMTP, HTTP. So these are the port numbers that are used for each of these services. Whereas if you, for example, develop some new services like MSN Messenger or something, you can use any port in the range of the registered TCP ports. The third category here is very important, and this is private and dynamic port numbers, which means that these ports, the ports in this range, gets assigned dynamically by the operating system. So if you open, for example, two browser tabs, so the each browser tab gets assigned a port number in this range. So different applications, when they first start, the operating system will assign source port numbers for these applications in that range. So this is a dynamic range which is assigned on demand by the operating system. Okay. So for TCP, these are the common services and the registered services, whereas for UDP, some of the well-known services like TFTP or RIP, they use these port numbers in the well-known ports, whereas these registered services use these port numbers in the registered port range. So sometimes you can run UDP and TCP at the same time, in which case you can use one port number to indicate TCP and UDP at the same time. So So multiple connections may actually use the same port number. So if you have one application that uses two connections, one TCP and one UDP, both applications may actually use the same port number in that case because they use different protocol in the transport layer. So the isolation here is done based on the transport layer. So each transport layer will then connect to the proper application using this port number, but the connections are separated by the transport layer protocol. So that shows you the different connections of TCP. So we can list the different connections of TCP by performing netstat command. So that shows you the list of connections that are done by TCP because netstat shows you the state of the connection as we have seen that TCP is the one that maintains the connection. We can see that all the connections are TCP here. There is no UDP because UDP is connectionless, as we have mentioned before. So this is the protocol type, and the second field shows you the source port. So this is the local host, the name of the local host or the local machine, and this is the source port. And as we can see, the source port here is in the range of the dynamic port numbers. The third field here shows you the remote server that this connection is connected to, and then this is the port number. This is the destination port number, which here is HTTP, which means that this is a well-known service. So if this is not one of the well-known services, then we have to put the port number in the range of the registered port numbers. But here all the services are well-known services, and in that case we put the name of the service. Okay, so this is the destination port number, and finally this is the connection state. We see that all the connections are established, which means that the connection is already up and running, and the communication is happening. Okay, so this part here talks about the order delivery. So even though both UDP and TCP, they use some kind of segmentation, we can see here that UDP datagrams or segments might be unordered because UDP provides a connectionless communication. So the data from the application layer are broken into segments that can arrive unordered in the case of UDP, whereas TCP guarantees the order of these segments to arrive on the other side. So UDP provides a source and destination port. However, the order delivery is not guaranteed.